So the multiplicity, what is the multiplicity of 0? Positive 3. So we have positive 3 here, negative 2, and negative 4. So just some added conversations. The multiplicity of those crossing through are going to be odd, or in this case, 1. This is what I usually call a bounce or a bump. So it's bumping off or bouncing like a ball off the x-axis. And so a bounce is going to be a multiplicity of 2. Remember, 3 kind of flat lines, 4, 5. So evens are going to bump theoretically, and then your odds are going to cross through. So, but 1s and 2s are what you want to pay the most attention to and make sure you know. So multiplicity of that positive 3 is a multiplicity of 2 because it bumps. So what degree polynomial is illustrated here? We see that it's decreasing, increasing, decreasing, increasing. That's 4 directional changes with 3 curves or 3 turn points. So it is going to be a 4th degree polynomial. Also, you would know that by that negative 4, negative 2, and 3 multiplicity of 2, because that's 4 roots or 4 zeros, and that's x plus 4, x plus 2, and then x minus 3, and it can be written as such. Or remember, though, that this, if you were having to write your polynomial and actually go through and multiply, you're not distributing that 2. That is actually 2 factors, binomials of x minus 3, x minus 3. So you'd have 3 to 4 terms, 3 terms of multiplication, 4 factors to multiply together to get that right. Now this next one's a little hard to read. It's a little blurry, but positive leading coefficient. So positive leading coefficient means that the right side will be going up. So as x approaches positive infinity, y is going to approach a positive infinity as well for our positive leading coefficient. It only controls the right side of your graph. So negative leading coefficient, also the right side of the graph, but that means that as x approaches positive infinity, y is going to approach negative infinity. So on the right-hand side of the graph, it's going to be going down. Even exponent or even degree means same. So if the right-hand side's going up, the left-hand side's going to go up. If the right-hand side's going down, which you get from your leading coefficient, your left-hand side's going down because it's an even degree. So 2, 4, 6, 8, and so forth. So odd exponent or odd degree is known as opposites. So if the right side is going up, the left side is going down. If the right side is going down, then the left side is going up. I always read backwards. We're used to reading left to right, but most of this information is all relative to your right-hand side. So your positive leading coefficient controls your right-hand side, and then relative to it, the even or odd degree controls the left-hand side. So just to keep things straight. Now, some more vocabulary. When dividing polynomials, if there is a remainder, so that means when you divide it, there is an r at the end or a number left in the box if you choose to do the box method or things like that, then it is not a factor or a zero. Not a factor or a zero or root, solution, whatever you want to call it. So if there is a remainder, not a factor. If there is not a remainder, then it is a factor or zero or root, depending. So if it was x minus 2 and there is not a remainder, then that factor is a factor of the polynomial that you divided it into. But also that is saying that when x is equal to 2, that is where that it's going to cross on your graph. So it is a root or a zero there as well. All right, this one I'm not really sure. I think this one we missed a lot because we weren't reading. So odd degree means opposite. And negative leading coefficient, so negative leading coefficient. So negative leading coefficient controls the right-hand side of your graph. So it does control the right-hand side of your graph. And it's negative, so it has to be going down on the right. So if we're looking at these, this one's going up to the right, this one's going up to the right, this is going down, and this is going down to the right-hand side. So we can get rid of these two. Odd degree lets you know that it's opposite. Both of these are going down. This is going up, so our answer should be C. So an odd degree polynomial with a negative leading coefficient. Just for conversation, 1, 2, 3. That is going to be a 3-degree polynomial because there are 3 directional changes. It looks like there's a 0 here and a 0 here. That's a bump, which is going to be a multiplicity of 2, and then the cross through would be a multiplicity of 1. Now, this one had drop downs on our quiz. So as far as we have x cubed plus 11x squared plus 7x minus 27, again, making sure you can read it. Is x plus 10 a factor? So yes or no. Is x plus 10 a factor? You could do this lots of ways. You could synthetically divide, which I will probably do this time just because we haven't done any of this for this review, just for practice. You're going to make sure that 3, 2, 1, none is perfect. Your first term falls down. We're going to take that negative 10, multiply, and it bounces up, which gives me a negative 10. And when we rewrite it, I was being lazy. This x cubed, x squared, and x are not there when you write out your synthetic division. Totally being lazy. Sorry, guys. So work straight down. We have another 1. We add when we go down. So negative 10 times 1 is another negative 10. So 7 plus a negative 10 is going to be a negative 3. 10 times a negative 3 gives me a positive 30. When I add straight down, that gives me a positive 3. This is a remainder. So as we just spoke in the question before, if there is a remainder, then it is not a factor. So our answer would be no, it is not a factor. The second question is, how do you know? And it's because there is a remainder of 3 when you divide all the way through. The other way you could do it quite simply is plug in that negative 10. So negative 10 cubed plus 11 times a negative 10 squared plus 7 times a negative 10 minus 27. And when you plug that in your calculator, you should get 3 as well. Obviously, you could long divide. You could graph it in the calculator and look and see if it touches the x-axis at negative 10. So does that graph touch at negative 10? If it does not, then you know it is not a factor. There's lots of ways to decide if it is a factor or not. This question was really discussing the fact that there was a remainder. So remainder theorem or division would be your best calls to get part 1 and part 2 of this question correct. All right, guys, that's our polynomial quiz. Hopefully, again, this ironed out all or any misconceptions. Reach out, come see me for tutoring, ask help. It's definitely going to be on your EOC, guys. All right, hang in there.